All right, so here's the practice sheet, homework sheet. Hopefully you did it by yourself first. And now you can go through the video with me if there's any problems at all. So can you evaluate it? So at -4, I need to know what piece. So -4 is smaller than -2. It's the top piece. So I plug -4 into the top piece. A negative times a negative times a negative is negative. That gives me -64. Take away 1 and you get your answer. -2, it belongs to the bottom piece because of the equal sign. So 3 times -2 plus 5, and then solve it, and you get -1. -7, decide what piece it belongs to. It belongs to the top because of the line underneath. And then plug it in and evaluate it. 4 belongs to the middle piece. So it's 3 times 4 plus 15. So that's the square root of 27. Number 3, 1.2. That belongs to the top piece. So the greatest integer less than or equal to that. So it's 1. Oh, it's 3 times that. Let's try that again. So if I go 3 times that, I get 3.6. Less than or equal to, I get the answer 3. Is it negative? It's -1.2. So 3 times -1.2. -3.6. Less than or equal to. That's -4. I'll get there. 2. That's the bottom piece. Thank goodness. Hopefully I can do that. The absolute value of -2 plus 5. That's 7. 4. What piece? Top, middle, or down? So the middle because the line under the arrow. So -5 squared, subtract 5 times -5. So it's 25 plus 25, and that's 50. 8 over 15. Well, that's a little bigger than 0. So that's the bottom piece. Good practice. 3 goes into 15 5 times. 2 goes into 8 4. So it's really 4/5 plus 7. I like life easy. It's 7 and 4/5. If you wanted to, 5 times 7 is 35. Plus 4 more is 39 over 5, if that's what you want. Number 5, can you graph it? So the top piece is a parabola. The bottom piece is just a line. And can I understand the domain restriction? That tells me where to stop or where to end the graph. So I'm going to start with 3. So when you plug in 3, 3 squared is 9 and half of 9. So it's -4.5. So at 3, I go to -1, 2, 3, 4.5, and it's a hole because it's just an arrow there. I know that the vertex is at 0, 0. So it'd be helpful to at least find a couple other points that are there. So if I plug in 2, I get the answer -2. If I plug in 1, I get -0.5, and then I can reflect over to get more points. The bottom piece is easier. It's a line. Plug in 3 and you get 7, and it's a point. And the slope is down 1 and to the right 1. And that's it. So draw a line, down 1 and to the right 1, and that's it. So the domain is all real numbers. The range, the bottom of it's -infinity, but the top is up here at 7, and it's included. Is there any discontinuities? Well, there's a jump. So at x equals 3, you can see a jump in the graph. Let's see how you did on the backside, practicing. Domain, range, and discontinuities. So what's the top piece? It's a rational, and the bottom piece, it's a line. Let's start with the easy one, the line. So if I plug in 3, the 3's cross out, and you get 2 take away 4, which is -2. So I got 3 and -2. It's a point. So I go to 3 and -2, put down the point. The slope is 2/3. So I go up 2 and to the right 3. and it's going forever to the right, starting there. The second piece is irrational. I tend to look at the denominator to get a sense that x can't equal positive 1. That's the vertical asymptote. So I'm going to go there. That's part of my picture, is that asymptote, because 1 is less than 3. We also have a horizontal at 0. So I want to pick a point. So I can put in 3. That's going to be an important point. So 3 actually going to be a whole. So at 3 take away 1 is 2, and 2 divided by 2 is 1. So at 3, 1, we have a whole. Here. But now I need another point to the right there. So I'm going to plug in 2 to get another point. So 2 will give me the answer 2. So I see the direction here. Remember, when it hits the vertical asymptote, it'll either go to infinity or negative infinity. So you can see where that one's going. I need a point on the other side, so I'm going to plug in 0, and that gives me negative 2. So I can see what's happening here, and finish off that part of the rational function. The domain is all real numbers, but x cannot equal positive 1. The range is all real numbers. So when you think of the line and include the rational part, it goes forever, top to bottom, just the pieces put together. Is there a discontinuity? There's 2 of them. So at x equals 1, there's a vertical asymptote. And at x equals 3, we have a jump. Number 7. 3 pieces. So the first one is an absolute value. The next one is a horizontal line. And then the bottom one is a parabola. So it's good to at least know what each piece looks like first. Doesn't matter really. Start with the top piece, negative 2. So I'm going to plug in negative 2. It's going to be a point there. So negative 2 plus 4 is 2. The absolute value of 2 is 2 times 3 is 6. So at negative 2, 6. And it's a point. Now, this vertex is at 0, and or at negative 4 and 0, which is part of my restriction here. So negative 4 and 0. So I'm going to connect these two together. I see the slope is 3. So it's both positive 3 and negative 3. So there's the picture to the left. That's the top picture. The middle is going to be a horizontal line at negative 2. So at negative 2 is a hole. And then at positive 2, it's a point. And then this one's the easiest picture, just a horizontal line that connects them. And then the last one is a parabola. So the vertex is at 0 and negative 11. That's not in my picture, the vertex. So I'm just getting part of the parabola just increasing at the end. So when I plug in 2, it's a point. So at 2, 4 take away 11 is negative 7. So at 2 and negative 7, be helpful to get other points. At 3, you get negative 2. At 4, you get 5. If they're on your graph, you might as well put them down. And now you get a beautiful picture going up. And you have the whole piecewise together. So the domain is all real numbers. Here, we have a bottom value at negative 7, and it's included, and it goes up forever. Where's the discontinuities? So we have a jump, when x equals negative 2. We have another jump when x equals 2. Number 8. So the top is a square root. The middle is an absolute value. Oh, I said EB. And the bottom is just a line. Start with the easy part. The line at the bottom. Plug in 1, and you get the answer 2. It's a point because of the line underneath the arrow. So at 1, 2, we have a point, and the slope is 3. And then I just draw my line from there. So there's one piece, up 3 and over 1. The middle piece is a V. The vertex is at 0 and negative 7. That's part of this. 0 is a part of it. So it's 0 and negative 7. This is in vertex form. That's why I know it. 0 and negative 7. I'm going to plug in 1, and I get negative 5. It's a hole. If I plug in negative 4, I get 8 take away 7, we'll get 1. So at negative 4 is 1, and it's a hole. Now the last piece is a square root, so I'm going to start with negative 4. So if I plug in negative 4 here, I get negative 4 plus 3, which is negative 1. A negative times a negative is positive 1. So it's negative 4 and positive 1. That's exactly where I just was at negative 4 and positive 1. So it actually fills in the hole. Oh, it's a hole there too. I thought there's a line underneath that arrow. So that's a hole too. I'll just make it bigger. There's a hole. Plug in numbers smaller than negative 4. That makes sense. So negative 5 gives me 2, which I don't care about. So I want to go to negative 7 because that gives me 4. And the square root of 4 is 2. So negative 7 and 2. So there's the picture. To the left, this is a hole, and we have a jump there. So what do we have? The domain. Is there any restrictions here going left to right? No. So the domain is all real numbers. Well, there's one that x can't be. It can't be negative 4. So at negative 4, we don't have an answer. There's a hole there. The range from the bottom to the top, again, it's all real numbers, but the one answer that x can't be is negative 1, or y can't be. So there's an exception. Or positive 1? Positive 1. The discontinuity, there's 2 of them, or 3 of them. So there's one there at x equals negative 4, it's a hole. And then there's another one here where there's a jump when x equals 1. There's a jump. All right, last one like this. 3 pieces. Let's do this. Top piece, what is it? It's a line. Middle piece is a cube. And the bottom piece is what's called a greatest integer function. It's going to look like steps. So let's graph this. Start with the easy one, the line on top. So plug in negative 5, and the answer is positive 5. It's a hole, and the slope is down 1 and to the right 1, but I'm going the other direction, so I'm going to go up 1 and to the left 1. And looking left to right, you can see the slope is negative 1, but it stops right there at the hole. But it goes forever to the left. The middle one's a cube at negative 3 and positive 5. That's going to be your point of inflection at negative 3 and 5. I need to plug in -5 and get an answer. So that's 13. Right. No, -5. That's -8 plus 5. So that's -3. So at -5, you get -3. That's a point. So a negative times a negative times a negative is -8 plus 5. I'm also going to plug in -2, so I can see the picture here. So when I plug in -2, I get 6. And it's a whole. And then the last piece is a greatest integer function, which is like steps. So I'm going to start with -2. When it's an integer, it is what it says. So it's going to be -2. And 2 times -2 is -4, plus 1 is -3. So at -2, we go to what did I just say? -3. That's a point right there. And then we're going to do steps to the next integer. And that 2 means I'm going to hop over 1. So count up to, next step. Up to, next step. The domain for this is all real numbers. The range, we do have a bottom value, which is at -3, and it goes up to infinity. The discontinuities. So we have a jump at x equals -5. We also have one at x equals -2. There's another jump, and then at every integer after -1. So at -5, at -2, and then there's like every jump there's a discontinuity in terms of that. There's at every integer there's a hole in a jump. All right, I'm proud of you. We work through it, not easy, but what we don't get easily, we keep practicing and try to get stronger, understand more the next question, and not give up and go backwards. Excellent. Mr. G Math, over and out.